Hello. Before I get into anything too technical, uh, I want to ask you something. How many of you have seen one of those videos where someone types a description into an AI tool and a full 3D character just appears in about 30 seconds? The video is real. That's actually happening. But what I want to talk about today is what happens after the video ends, because that's where the actual and useful story is. And I want to be upfront about something before we go any further. I'm not here to tell you how to feel about AI in games. The concerns people have about it are real, and a lot of them are completely legitimate. What I am here to do is to give you a clear picture of what these tools actually do right now, because the conversation on both sides tends to skip past the most interesting part. So, if you follow gaming news or game dev communities at all, you already know the temperature on this. Studios have lost industry awards over AI use. Developers have signed public statements against it. Players are reading terms of service, looking for AI clauses. This is not a fringe position. It's pretty much the mainstream sentiment of the field right now. Some of those concerns are about economic displacement of working artists. Some are about how training data was sourced. Some are just the quality of what these tools currently produce. And here's why I'm telling you before we look at anything technical. To actually understand these concerns, including the economic ones, including the quality ones, you first need to understand what these tools are actually producing. Because once you see that clearly, the conversation about where humans still fit in gets a lot more specific and a lot more honest. So let me show you what is actually coming out of these tools right now. Now, let me define a couple of terms so we're working from the same picture. All right. A mesh is a 3D geometry of an object. You can think of it as the shape itself before any color or surface detail is added. Just the structure. Okay. Now, textures are what take that shape and make it look like something real. And most game engines today use what's called PBR, which stands for physically based rendering. And here's why that matters. So when you're playing a game, the engine is calculating the light in real time, every frame as your character moves around. To do that calculation correctly, really, the engine needs a separate pieces of information. It needs to know what color the surface is. It needs to know how shiny or how rough it is. It needs to know where tiny surface details like bumps and scratches are. It needs to know where parts of it behave like metal and parts of it don't. So instead of one image, you get a set of maps, right? Albedo is the base color. Normal is the surface detail, but without adding geometry. Roughness and metallic tell the engine how light bounces off of the material. Okay, this is how most modern games and modern game engines work. A tool like Hunyun 3D from Tencent takes a text prompt or a set of reference images from multiple angles, and it produces a mesh with all of those maps in about 90 seconds. On the screen, that result looks genuinely impressive. And I want to be clear, that part is impressive. There's something even more interesting kind of going on here that we need to discuss. So, what we're really looking at is production ready or not, right? Is what it produces, which looks visually good. And you can hear critiques that say things like, it got this wrong or that wrong or different things. But, the truth is, looking at these models and looking at what they can produce some very impressive things. But can they produce something game ready? Can they produce something production ready? An asset that runs correctly inside a game engine. No performance problems, no glitches, no broken lighting. That's the bar. And what comes out of an AI tool is usually not there yet on its own. And here's why. The first issue is topology. So topology is the way the polygons in a mesh are arranged, the actual surface. Good topology is organized. The shapes are consistent, usually four-sided. They follow the form of an object in a way that bends and deforms predictably. Think of it like origami. Good folds go where you expect them to go. Bad topology is the opposite, right? It causes problems when you try to animate it because the model isn't quite optimized for animation, or meant to bend in the way it needs to for your scene. AI generated topology is improving, but is frequently inconsistent. It often needs a human to go in and correct it. The second issue is the UV layout. A UV layout is how the mesh gets unfolded flat so a texture can wrap around it correctly. If the UVs are messy, the texture doesn't sit right on the surface. You could get stretching, seams in the wrong places, distortion. That can help with visual issues inside the game, and this sometimes needs cleanup. Okay, the third issue is texture baking. The maps the AI produces sometimes need to be converted into specific examples your engine expects. Different engines pack that information differently, and a human has to make sure that transition happens correctly. Again, these texture maps, these these programs are producing look good, but they're kind of almost as if you just auto unwrapped a model. We've had auto unwrapping tools forever. It's easy to say flatten a model out and not care how many pieces, where the edges are, how it lies, or any of that. And that's kind of what these models are doing. They're flattening it out and they're painting the texture directly on the surface. So it looks good at the end, but if you actually look at the texture maps that these things produce, they're colorful, blurry messes, right? They're all over the place. You couldn't edit a texture, or if you need to make an adjustment to a color of an image or part of an image, other than painting on the model itself again. That's kind of your only recourse of action. So essentially, in a traditional development pipeline, an artist might create a high polygon model, and then they would need to create a lower retopologized or lower resolution version and project all those details on. These generation tools, they can do most of that first process, which is kind of the fun process some of the time. So, there's that, but they can create that high polygon model with lots of details. They can create a base mesh that looks pretty good, maybe not perfect, but pretty good. But you still have to do the rest of that pipeline, right? You're still creating the lower resolution model, and you're still baking all of those textures onto it. Now, if you do all that, it works pretty well. Again, it can replace the first part of that pipeline, but you're still having to do kind of all of the rest. Now, the last thing is rigging. So rigging is actually preparing the animation for the model for animation, so creating all the bones. And a lot of the tools are starting to add these, which honestly, of all of these, are getting pretty good and pretty usable. But it still needs a human to review it and make sure it bends and animates cleanly. Now, none of that is a failure. This can be like automate maybe 80% of the workflow, right? Again, I talked with a game developer the other day, and they were saying that they could take something that would normally have taken them 6 hours to produce, and they can get something working off of using AI in their game in 30 minutes. Is it completely automating the workflow? Is it completely taking out all of the human elements and all of that? No, that's, hype. But is, a 6-time reduction in time, right? And 80%, this can get you 80% of the way there. That's enough that it's worth note, right? That's the conversation. That's where it's kind of worth, delving into. So, texture corrections that, need to be worked on, modifications, those kind of things. These are all still entirely human work, and it's that part that's kind of separates something that was generated from something that was made. So, the definition of how much is still human kind of still becomes something worth a little bit of discussion. Now, but I want to spend a moment on the tools you can actually get your hands on now. So the best way to really understand these tools is to kind of see them in practice, right? Now, this gets left out of the conversation a lot. You see YouTube videos where people are going to present these tools on how they work and just kind of talk about them, that maybe don't actually utilize the tools. You might even get some people that have used the tools, but there's not a lot of discussion about the tools themselves. Now, Meshy and Tripo are the two most commonly covered kind of Western tools in the space right now. You hear these talked about a lot. The quality they produce is solid and generally worth knowing about. But if you want to actually experiment with them, you'll hit a wall pretty fast. So you can generate models on there, but downloading them costs credits. So even the free tier runs out before you can do much testing or actually, you know, put these models to the test. Hunyuan 3D, it's from Tencent. It's a completely different situation. You get 20 free generations a day, 30 free creations a day through their studio platform. You know, basically that's maybe 50 different things you could create in one day. That's going to roll over every 24 hours. This means that you can really kind of experiment and try it. On top of that, this model is open source. So if you have the hardware that can run it, you could be running this locally on your own machine. I will say the rigging it includes actually is genuinely capable for a free tool. It does a pretty decent job. However, I'm not telling you this is a product recommendation because that recommendation would probably be outdated within a year. I'm telling you because this landscape is shifting from closed and paid toward open and free, and that shift is worth watching. There's another piece worth noting. The company offering the most accessible and fully featured tool here is Tencent, a Chinese company with one of the largest game studios in the world. Western alternatives cost money to actually use at a meaningful level, and that gap at how these tools are being accessible is a real conversation in the industry. And practically speaking, it means the best free tool for a student that wants to learn right now might not be the one getting the most coverage. So this all kind of comes down to it's a fast moving space. 2 years ago, the main criticism about AI image generation was about 6 fingers and 3 arms and faces that looked melting. You've probably seen plenty of examples and videos like that. Those problems are not completely gone, but the conversation has clearly moved on from them. The tools improved faster than most people predicted and slower than hype suggested. That same trajectory is happening in 3D generation. The rate of improvement over the past year has been significant, and the gap between what these tools produced 18 months ago and what they're produced today is not subtle. How long until the 80% becomes 90 or 95? And my honest answer is longer than most enthusiastic coverage will tell you, and shorter than a lot of the game development is hoping for. And this is the most important thing I want you to take from this. Memorizing which tool is the best right now is kind of the least durable thing you could do with your time. By the time you finish a semester, the list might have changed. What travels with you is an understanding of how the pipeline works, where AI enters it, where human judgment takes back over, and how to read the direction of change accurately over time, rather than just reacting to whatever demo went viral. That skill holds value, regardless of what the tools look like in 6 months. So, AI tools produce a really fast first draft. A skilled person finishes it. Being able to create a nearly complete model, even if the model itself, even in the very first part, isn't 100% exactly accurate, the fact that in 90 seconds it can create a high resolution, highly detailed model with a base texture map, all kind of ready for you to use, is significant, right? That's worth note. That 80% is real and it matters. The work that remains is still human because you're still going to have to take that and make it into something usable. It's true that you can generate a 3D model and maybe 3D print it. Again, we're talking about game design here, but are those models usable as is? Already that answer is becoming yes. But it's important to note kind of where we are. Now, in this 20% that end here, that part still stays human. It's not just the tedious part. It's the creative judgment part. It's the part that actually determines whether something works in a game. So you create it, again, you have to then finish it, right? Make it into something worthwhile. So the debate on whether all this is good or bad for an industry is legitimate and it's ongoing. And I'm not going to tell you where to land on it. What I hope you take from this is a more accurate picture of what is actually happening, because you deserve that version in one conversation rather than a simplified one. One concrete thing you can do right now is go to Hunyuan 3D Studio, make an account, generate something from a text prompt or an image, open that result, and actually look at it. Look at the topology, look at the texture maps, like what I was talking about. Ask yourself honestly, what would I still need to do to get this into a real game? That question is worth sitting with. Okay, the last thing I want to say is just thank you for watching. Here are a couple of key terms for reference. Again, if you were new to those terms or you hadn't heard them before, I will say the debate about AI isn't going away anytime soon, but the impact these tools are having, are going to have had, and all of that on our industry is absolutely something we have to be following. It's something we need to be aware of. And I tell my students when I teach them my classes, you know, it's not so much whether or not you use AI or not. It's not whether or not you want to use or don't want to use or whatever when it comes to AI. What you do have to do is you have to know what can it do? Like, what is it doing now? What can we do with it? What is it able to do? Because being unaware doesn't change anything else. All it does is make you unaware. So, thank you so much for watching and have a good one.